Alright, so if we take a look at number 32, they tell us that we have a hockey rink, all right, and they give us this drawing. These are the boards, all right, and they tell us that we have the puck at 0, -4. It hits the boards. We're going to count these by 2s and these by these by 1s here, and then it ends up 2, 4, 6, 8 right here. So this point here is -4, 0. This point here is 0, 8, and this point here is -4, 16. Okay, and this is the puck ricocheting off the boards. And they want to know, the question is, in the end, they want to know, does the path of the puck form a right angle? All right. Well, for the path of the puck to form a right angle, what do I know about the slopes of these two lines for this to be a right angle? This is what we're looking to determine if that's a right angle. What do I know about the slopes of those lines? Joseph? Yeah, so for these lines to be perpendicular, our slopes must be opposite reciprocals. All right, so Elle, do you understand how to write the equations for both of those lines? Okay, so I'm going to call this line line A, and I'm going to call this line line B, just for the sake of giving them names. So line A, the equation says an equation that of the puck of the blade to the wall. So this is y equals 2x plus 8. And then line B is the puck after it bounces off the wall is y equals -2x plus 8. So for us to answer part C, this is puck A, this is equation A, equation B, we need to look at our slopes. L, are those opposite reciprocals? No. So these are not opposite reciprocals. So not perpendicular. Is what I would say there, and how I figure that out. Okay? Yeah, Ashley. Yeah. What else can I do for you guys? Yes. 33. God bless you. Let's take a look at number 33. 33 said, while nursing, blue whale calves gain weight at a rate of 200 pounds per day. So we have whales. Let me spell that right. They gain 200 pounds per day. All right. Two particular calves weigh 6,000 pounds. So we have calf number 1 is 6,000 pounds. And then we have calf number 2 is 6,250. So 6,250 pounds. All right. So here are our givens. Write equations that model and these were at birth. All right, it said write equations that model the weight of each calf as a function of the number of days since birth. So we want equations. In this type of, when I write the number of pounds as a function of number of days after birth, what form of my linear equation do I want my equation in? When I have this phrase, do I want standard form or do I want slope-intercept? Giselle? Yeah, we want to put this in y equals mx plus b. All right, so we need to identify those things on here. First of all, my y is going to be my number of pounds. My x is my number of days since birth. All right, so for calf number 1, I know the slope of both of them. The slope is that m value, is that 200. So I have y equals 200x plus. Well, what do I have, what information do I have to either that is my b value or will help me find my b value? Okay, someone tell me, what does x represent? What information does x represent? Lily? Okay. What information have they given me for both calves? Molly? Number of pounds at birth. So how many days after birth is 6,000 pounds for that first baby? How many days after birth? L? 0. So what is that 6,000 for calf number 1? Ryan? That's our y-intercept. Remember, our y-intercept, when we talk about our y-intercept, our y-intercept is like a one-time cost. It's an initial value, but it's also the y when x equals 0. That's our y-intercept. It's our y when x equals 0. And if you didn't know that, all right, we could simply put a b here. And then you could substitute 6,000 in for your amount, your number of pounds, and come up with your b. All right? And the number of days after birth would be 0. You could come up with your b value. All right? But since I know my y-intercept is always when x equals 0, whatever that y value is, at birth, x equals 0. Because there are 0 days since birth. So these are both my b values. All right, so for my first one, it's y equals 200x plus 6,000. And for my second one, it's y equals 200x plus 6,250. So there are my two equations. Then it says, how much is each calf, how much is each calf expected to weigh after 30 days? Well, who asked me for this? Okay, do you need me to go any further other than that? All right, because I think we'll have no problem evaluating part B for 30 days. And then it says, how are the graphs of the equations from part A related? All right, they should be parallel. All right, and we know they're parallel. How do we know they're parallel? They don't really tell us to graph it, but if we had to graph it, what do we know? Seamus? Their slopes are the same, so they're parallel. That's what I would have written for part C. What else can I do for you guys? Giselle? All right, let's take a look at 19. So 19, the directions for this says write an equation of the line that passes through the given point and is perpendicular to the given line. All right, so we want a perpendicular line. All right, so for 19, our point is negative 9, 2. And our given line is y equals 3x minus 12. Okay, now, the first thing first of all, for me to write an equation, I'm writing it in slope-intercept form. Y equals mx plus b. The only thing I need from that given equation is the slope. All right, so if our slope from our given equation is 3, what is the perpendicular slope? If my slope from that given equation is 3, what is the perpendicular slope? Rita? Negative 1/3. It's the opposite reciprocal of that first slope. So our given line slope is 3. a line perpendicular to that is going to have a slope of negative 1/3. All right, so now I'm going to use that slope in my given line to find my v value, or my given point. So I have my new slope and my given point. So I'm going to substitute the y and the x in, so 2 equals negative 1/3 times 9 plus b, and I'm going to find my b value. I'll divide out common factors here, so I have 2 is equal to negative 3 plus b. B is equal to 5. So our equation is y equals negative 1/3 x plus 5. Does that help you? Excellent, Joseph. Negative 9. Yeah, that should be negative, so this is going to be positive. So let's just make that adjustment. Thank you for correcting me. That's going to be negative, and this is going to be a negative 1. So this is going to be minus 1 or plus a negative 1. Thank you for correcting me. What else can I do for you guys? Awesome. All right, put this away. Get your notes out, please. Okay. All right, so today is the 7th. You guys need a ruler, so please get a ruler out. This is our second to last section. All right, we have 4.7 as well. All right, your chapter review I will be giving to you on Friday. It's going to be due on Monday, and then we have a test on Tuesday. Okay? So you can start preparing. You know, what might be a good idea is just to now start kind of looking through the beginning of the chapter, just because it was so long ago. That might be a good idea for you guys. All right, so we are in chapter 4, section 6. We're going to be working on things called a fit align to data. All right, another way of what we're talking about are called lines of best fit. That's another way of talking about what we're going to be doing are called lines of best fit. All right, so let's take a step back and start from the very beginning of this. Okay. We are going to be using actual data. All right, so we're going to be using actual data. When we take surveys of things, we're not always going to get the data is going to be creating a straight line, right? We might have data that we could say, all right, if we looked at the high school placement test grade for this class, right? I could have, or for my advanced class over years. Let's say I do that. So I take my 8X class and I look at starting like maybe in 2000 and let's say 2015, and I look at it all the way to date. Okay, I would look at the year. So my X would be my number of years since 2015. My Y would be the score. Okay. And I could create what we call a scatter plot, right? I could create a graph of that data. Chances are, and maybe I take the average, like I take the average of your scores in here, okay? And I will look at the average scores of my 8X class, okay? I don't expect it to be a straight line. I expect it to be a little bit off here or there. Hopefully they're getting better, right? They could go down, they could remain the same, but I can make a scatter plot. So we are going to be talking about using these scatter plots. Scatter plots are snapshots of actual data when you relate two pieces of information together. We'd be relating number of years since 2015 to the average score of my 8X class. We could see, hopefully for my benefit, for me to see if I'm doing a good job, hopefully the scores are going up. Right? The average score is going up. but I can see that. Hopefully it's not going down, because that means that there's something wrong with how I'm teaching it, or maybe, it might show that students are not being quite as capable as years go along. Like, we could probably see those trends. All right. So when we use actual data, what we do with actual data is we create graphs to see the relationship between information that we're comparing. Okay? So when we use actual data, what we also take a look at are things called scatter plots. And I know that we've talked about this before. I think in one of the previous chapters we talked about scatter plots and correlations. I think we've done that. Do you guys remember talking about that? Okay. So we're back to scatter plots. And what scatter plots are these are graphs showing a relationship between two sets of data. All right, and the way we use scatter plots is to see, is there a relationship? We want to know, is there a relationship? All right, and if there is, if yes, what is the general trend, I'm going to say trend, and we're going to talk about what trend is, of the data. We want to know, in general, what is the trend of the data? All right, that's that correlation. Do you guys remember us talking about positive correlations and negative correlations? This is the same thing as a correlation. Or what that means is we want to look at what is happening to the Y info as the X info increases. That's what we're looking to figure out. In the previous chapter, all I said was this is a positive correlation or negative correlation. All right, if we find there is a correlation, that there is a relationship that we can determine, what we can do is we can draw a line, like an average line running through the data for us to use to predict. And that's what we're going to start doing tomorrow. Today, what I want to talk about is, I want to talk again about correlations and what these trends are, and I want you guys to practice creating scatter plots again. So when we get into lines of best fit tomorrow, you've already gone through redoing scatter plots. All right, I want to make sure you guys are good with that. So let's talk about our correlations. There are three types. All right, so I'm going to show all three here. I'm just going to make a little graph, just a little first quadrant, three of them. Just going to put them next to each other here. Okay. So I've just created these for little first quadrants, these little quick graphs. All right, and I'm just going to put some data on here. Let's say that's my data. It doesn't have to be exactly like mine, just have it look similar to that. All right, here we're always saying to ourselves, as X is increasing, what is happening to Y? All right, so as X increases, what is happening to my Y values? So as my X is increasing this way, what are happening to my Y values? Are they increasing or are they decreasing? Or nothing, like there's no pattern. We're looking for a pattern. Natalie? Yeah, Y is increasing. Y, as X increases, Y increases. What type of correlation is this? Do you guys remember what this would be called, this one? Lily? Yep, that's a positive correlation. All right, so let's do the same thing. All right, what's happening to my x's as my y's? What are happening to my y's as my x's are increasing? So we always say as, let's put as in front of that, as x increases. What are happening to my y values on this one as my x's are increasing? And it's in general, it's not all of them. But if you look at the trend going on here, we kind of look at, if we do these little guidelines, we can kind of see this, in general, this is going up, and in general, these are going down. So as x increases here, our y decreases. This is just in general. So what type of correlation is this called? What is it, Rita? That's a negative correlation. The third one is called no correlation. And that's when we just kind of have random dots. There is really no relationship at all. We can't really come up with any relationship. So there is no pattern. All right, so I'm just going to show you these graphs, and I want you to tell me what type of correlation. These should be easy for you. All right? Who needs to see what's up there? Okay. So if I take a look at this graph, first of all, always analyze it for what we're talking about and what the data is. Then you're going to tell me what correlation it is, and you're going to explain. What I want you to do is in these, we want to describe the graph. All right? I'm not going to have you guys necessarily reproduce this because I want you guys to, we're just going to talk about it. I am going to have you create a scatter plot, so we'll do this in your notes. All right, but let's practice this first. All of you look at this, analyze the data and what it is that we're comparing, and then somebody tell me what correlation we have. And then I'm going to have you describe it. All right, so what are we comparing here, first of all? What are we analyzing? Giselle? Excellent. So we're looking at the number of hours we're studying and how that may affect our test scores. Do you see a relationship here? Okay, so what type of correlation do you see? Okay, so explain to me why. Don't just say as x is increasing, y is increasing. Use the data. Excellent. That's the description. Okay? So you're saying what is happening, and the X information will always be increasing. So we're always going to be saying as the hours that you are studying are going up, and then tell me what is happening with the Y. Our test scores are also going up. And that's in general. Not always. You can see that that's not always the case, because it dropped down here. It kind of leveled out a little bit up here. But in general, that's what's happening. All right, so all of you take a look at the second one. So analyze this one, and then do the same thing. Tell me if there's a correlation, and explain it to me. Carmen, what do you think? Okay. Okay, so describe the correlation to me then. Excellent. How many of you guys agree with that? Absolutely. Okay? Are you guys good with how I want you to describe it to be able to understand what you're looking at? Okay. So what I want you guys to do is I want you guys to do this problem. To make this this easier, just round those to 37, 19, 21, 26, 26, okay? So just round those, or maybe make the second one 20, that last one 20 is 27. Round those lengths to the nearest whole centimeter, okay? That'll make your increments easier for this right now, because we don't have a ton of time left. This is example 2 on page 265. So let's round those properly. So that first one will be 38, 19, 21, 26, and then 27. Now remember, when you're graphing these, you don't have to have the same number of the same increments on both axes. All right, you can. I would highly. Let me think about this. Because of the information, can we do a graph break? And because we aren't going to be adding any more fish to this, we probably could do a graph break to make this a little bit easier on both of them, don't you guys think? Right? So yeah, I think we could probably do a graph break on these. It's going to make graphing these a little bit easier, and probably on both axes might be helpful. But we don't ever want to do a really tiny graph, because then they're not readable. When you label your axes, make sure you label it with the information and also the units. So when you write length for your x-axis, remember your x-axis is always, your x information is always your first row or column. Your y information is always your second row or column. So if you do a graph break on your x-axis, what are you going to count by once you've done your graph break? Joseph, what do you think? Fours? Twos. I think twos. I think fours might be too big. I think twos is good, right? That makes a good one. So I'm going to do the same thing. Did you start at 18? You start at 15. Start at 16 then if you're counting by twos, because that might be easier to count by twos. Unless you, I mean, you can skip count by twos with odds. That's fine. And on your y-axis, what did you guys count by? On your y-axis. So I've got to go from 47 up to 148. What would make sense? Rita? What about tens? Let's see what that does for us. So that's, and what did you start counting at? 40? Okay, so if I start at 40, that's 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50. Yeah, I think that probably is a good idea. Don't you guys think maybe tens? Otherwise, so when I do that, this is how big my graph is on my page. I mean, it's about half a page, maybe a third of a page. And counting by tens, if I count by fives, it's going to make it a lot bigger. All right, so I think tens work. Don't forget, you need to draw your little increments. So 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50. Remember, graphs are not always super accurate. The smaller the increments, the more accurate the graph. These are just approximations. So my graph looks something like that. Is that what you guys have? Kind of? Okay. So what type of correlation is this? And describe it from there. What type of correlation is this? And then describe it. Rafaela? So I would say a positive correlation, and then explain to me what that means. Excellent. As the length gets longer, the speed increases. Excellent. Hi.
Hi. Is this a new class or?
This is I'm sending them off to lunch class.
Okay. I'm going to turn this over to you.
Please. Happy.
I should have run off class list.
I'm happy.
I got that group. They were 8. Why? I'm going to see them. I guess I could have done this. This is not in order. I'm sorry. This is annoying.
You guys do questions? All right, you guys can go ahead.
No, don't go.
No, let's start packing up.
Anybody who's in the geography B needs to, this is so disorganized. It's 6th, 7th, and 8th. Needs to double check what room they're in. Just glance and find your name. And then the other group is 8. Who are you? 8 who? Okay, so 8Z.
Okay,
I'll do 8Z?
No, you will be seeing 8Z. I've already seen 8Z.
Oh.
I haven't seen 8Y. I can do 8Y.
I saw 8Y.